Okay, on the bench today we have this Diehl Junior Fan, and this was sent in from a customer, needs to have it repaired, and its catalog number B12AJ16. It's rated 110 or 120 volts, 60 cycles. Kind of dates it 60 hertz, 8.8 amps or 800 milliamps. And he doesn't want us to paint it. He likes the original paint, and he's probably gonna touch it up himself if he wants to do that. And this is our first look at the fan. It just came in today. And turns fine. The oscillator doesn't seem to be frozen. The head wires definitely have some issues. I don't know what happened there. It looks that both of them are like buckled in the same spot, at the same place. The grommet's loose. There's no grommet on the top. And it's pressed metal case. And it has a speed control for, looks like 2 speeds, high and low and off. And has a felt bottom, so a little bit loose. We can probably touch that up and get that sitting a little better. So now I'm going to plug it into, well, actually I think I'm going to check the resistance on this first and make sure there's no short here. This cord is really messed up bad. Somebody put a lot of tape on there, and it's definitely dry rotted. But I'm going to check it. If it's not shorted, we will go ahead and put it on current limiting bulb on the variac and bring it up slowly. So, okay, let me see. All right, I'm going to pause the camera here and put it overhead, and we'll continue. Okay, first thing we're going to do is check the resistance and see if there's a short. Switch is off. Close the cord. I'm not getting nothing. That's a good sign. So the cord may be okay, even though it's flaky. Okay, let's see, medium. I started to get a resistance there, and there it is. We're getting about 77, 78 kilo ohms across the coil, and I don't think I'm making good contact with these, so hold on a second. I'll just clip this on so I don't have to hold it. Okay, let's see what we got. Okay, we got 1.4 kilo ohms on high. Low, we don't have anything. There we go. And we got a problem with the switch. It's all over the place. There we go. Numbers flying all over the place, so I don't know what's going on with that switch. I'll probably have to put some cleaner in there and clean that switch out. Oh, well, that looks better. We shouldn't be in the K ohms. It's coming down. That's so weird. Nope. Okay. what's going on there. There's obviously some issues with the switch. Okay, but I don't see anything dangerously low, so we'll go ahead and try it. Shut it off, and we got nothing. Okay, no short. But just to be safe, come plug it into my current limiting bulb. Just a second. Okay. Bring the voltage up. Switch is off. I'm not seeing any issues there, so I'm going to go ahead and turn the switch on high. Okay. Okay, I'm on 52 volts. Not drawing any current. Nothing's happening there. We'll bring the voltage up some more. 65 volts. We should be having some action. We're not getting nothing. I don't think the switch is any good. That's weird. Okay, let me make sure we got voltage going to our current limiting bulb. Yeah, we got current going to it, so that's obviously the switch. What's the motor shot? Okay, I'm at 75 volts and I'm not getting no current at all flowing through that bulb, through that fan. So, next step is to open her up and see what's going on. First thing we're going to check is this power cord. I know we're getting through it because we were getting a reading across that switch, even though it was sporadic. I want to see what kind of damage we got here. Now that wire is totally shot. See that? Spaghetti's totally gone. Look at that. Okay. Well, I got the worst of that off. I ain't gonna take it all off till I get the bottom off the fan. Okay. Let's see what we got here. It looks like these spots here on this coil are very suspicious to me because these cables look fine. I don't see any damage on them anywhere except here and here. And it's almost like somebody tried to break through the installation, in this spot. Why would they do that? For this. Get in there and check the resistance across the coil and see if there's a problem. They probably did that rather than trying to take the bottom off here. You see this is peeled up. There's a screw there that holds that on. The other screws are covered, and they probably just, rather than trying to peel up the felt and have to glue it back down, they wanted to try to get in here and see what's going on, but that don't work. So we're going to take the bottom off. That screw is a mess. That's one little screw, that broke off. No, it didn't break off, it's just really corroded. Okay. Let's see if we can find the next screw. Okay, it looks like it's going to be over here, and there it is. Right there, and there's going to be one on this side too. I'll take all of them off. I'll just have to glue the felt back on after. These screws haven't been out of here in a while. Got some kind of corrosion or something on them. I don't know what that's all about. A powdery substance? I don't know. Maybe somebody put something on them to try to make them go in easier, because they are kind of tight. And it might have just turned the powder. We'll take that off. Okay. Oh, interesting. Well, now I know where the powder's coming from. It's this inner cardboard. See that? Gently remove that. Okay. Ah, there's the speed coil. So we set that aside. First thing we'll check is this switch and see what's going on with it. Could be these, let's say, original wire cap. The coil looks like it might have got hot. It's got some rust on it. It might have got hot, but we'll check that too. Let's start with the switch. Okay. Okay, we got 9 ohms across the switch. And yeah, the switch is faulty. See, I just move it a little bit, and the numbers are jumping all over the place. That's where one of the problems is. It's off. It's high. And we got nothing. I have to wiggle it to get it to work. So that switch is not working. So we will jump across the switch. And across the coil. Oh, look at this. This ain't even soldered here. See that? That solder ain't even connected to that wire. And I swear that didn't look like anybody's been in here, but I guess somebody has. Okay, let's check that switch again, and this time we'll actually try to check the switch. I don't know, it's got dirt all over the connector here. Let's not worry about the wire. I can solder that, but let's check that switch. No, we still got a problem with the switch. Okay. It got really, really hot. I don't know if you can see that there, but you see that wire's loose. And because that wire is loose, there's been a high resistance connection here between the terminal and the wire, Most likely it's been like arcing. You see all that soot? It's been arcing here because it hasn't been soldered good. And so the power is intermittent, on, off, on, off. I don't know what that did to the coil or the motor coil. We'll have to figure that out. But we know what it did to the switch. It really messed up that switch. So, and it's turning good, so I'm going to spray contact cleaner in it, and I might be able to fix that. But for now, okay, so the next thing to do is get rid of that line cord, because that's probably a big problem. Let's put this line cord on and see what we get. I'm just going to bypass this line cord altogether. No, the coil ain't warm. Let's try that again. This time I'm going to go ahead and put this new line cord on, and we're going to jump across here. I'll take this off. Disconnect that. Okay, now the old line cord is disconnected. We're going to put this new line cord on here. It's not the line cord I'm going to put on this fan. This is just to do some testing. Well, that wire nut is sure deteriorated. It got hot. Everything got hot in here because of that lack of solder joint there. And the other half of this goes here, which goes to the coil and comes here and jumps across here. This would be high, this would be low. So we're going to make it high. So what I'm going to do is just jump across here directly to the other side of the line cord. We're going to try that again. Okay, let's plug this one in and unplug that damaged cord. And one more look. This is going into the motor. This one is going into here, which is also going into the motor. Okay. So now we'll bring this back up. Drawing 140 milliamps to the motor itself. Get out of there. No. $11 watts. I should be turning that motor. That's on there. That's good there. That goes to the head. And that going to the head. Okay. We got 70 volts. $18 It should be doing something. It should be humming or something. It's not doing anything. It's not looking good. It's looking like this armature, this stator coil is shot. And I'm pretty sure that that's what they were trying to check when they were doing this. Rather than taking the bottom off, they were trying to connect right across the motor and see if they could get anything out of the motor. The coil, the speed coil is fine. The switch is bad. I might be able to get it working, but it's bad. But that's definitely making a good contact because we got current going through it. This got really hot, and it's all due to that bad solder joint. We got 22 ohms across the motor coil, across here. That's low. Boy, that's some awful solder joints. I don't know who would solder like that. I can't imagine that that would be the manufacturer. That's just terrible. Even this wire is a joke. It should be spinning, that fan. I don't see enough. I don't see a low resistance, a high resistance, or a short on my meter. So I'm not seeing a short. It's almost like that motor must have got hot, and some of the windings might have shorted out, but the entire armature, stator doesn't seem to be shorted. Now we're right across the motor. Bypass the entire switch. That's connected, that's connected. And this is everything safe. Let's see what we got. It's not looking good. I'm on 110 volts, and that motor is not even trying to turn. And I'm reading a dead, well, not quite a dead short, but I am reading a short on my current limiting bulb. I don't smell any heat coming out of there. Why, oh, why is this not spinning? It is possible that something is shorted in here. Alright, let me show you. I'm going to take my camera down so I can. Okay, I've got the voltage up to 121, so it's right about at its peak. The fan's not even trying to turn. I've got the line cord directly across these two wires that go directly into the motor. My current limiting bulb, you see back there, is bright as can be. So there is some kind of short. This is all disconnected. This coil's disconnected. The switch is disconnected. I'm just jumping onto that wire there, and I'm jumping onto that wire there, which is these two wires. And they go directly to the motor. Now, on 120 volts, the fan is rated at 800 milliamps. We're only drawing 270 milliamps, and that's okay. The rest of it is being swallowed by that light. But I don't like the idea of going directly into this without that bulb. However, I'm not getting anything on the fan, so I think the motor is already in serious trouble. Or maybe not. Maybe it is trying to pull. I can't tell. If it is, it ain't doing much of anything. Let's just try a direct connection. Okay, I'm going to bring the voltage back up. Now I'm just connected to the fan. I took my current limiting bulb out of the set. And right now our current is 270 milliamps, which is good. I'm at 60 volts, still going up. Now we're at 72 volts. We're drawing 500 milliamps. That should be turning. There we go. That's what I wanted to see. Okay, so now I'm going to turn the voltage up some more. And now we're at 91 volts. And the fan stopped. We got a problem with this fan. The motor is definitely not doing good. We're not drawing the 0.8 amps. We're drawing 0.7. We're at 91 volts and 37 watts, and the fan just stopped running altogether. So we got a problem with the fan. Geez. That explains these marks. Somebody was trying to, this fan got really hot because of a real bad solder joint here. And because of that, somebody was trying to jump directly across the motor, and that's why they cut into the cloth here, and try to get the motor to turn like I just did. But I did it the right way. I jumped the switch, and I jumped the low speed coil and directly connected directly to these wires from under here, not from cutting the insulation. That's a shame because these wires were in good shape. They shouldn't have done that. But I don't know what's going on in this motor. It's definitely got some problems. Now it's not even wanting to hardly turn. So it's got a, it's turning, but it's not turning good. And you've seen it was turning for a while. It never overheated, never drew the 8 amps, 800 milliamps it's supposed to draw, 0.8 amps. It didn't draw that. It could be that it's trying to oscillate, and I got it laying down. The only way I could find that out would be to solder this cord in directly. But I don't think that's it. I don't think it's trying to oscillate, because it should still be spinning. It wasn't spinning for long. I'm gonna have to take it apart. Man, I didn't want to have to do that. I've got this radio on my bench that I got to do for the customer before I can get to this fan. So I'm just gonna have to set it aside for now till I can take it apart and clean it out and check that stator coil. If the stator coil is bad, the fan is bad. That's the bottom line. The coil's fine, the stator coil. If it's bad, the fan's bad. There's no hope for it. Trying to find another stator would be very difficult. We may find one online, but not likely. Anyway, let me deal with this and put it together and see what I can do when I can get it apart. Okay, I took the back off this to see if I could see if this motor looked okay inside, best I can tell. We got some grease in there. You see the grease in there? So we got a lot of dirt going on in there. That stator looks like it's been fried. See those copper wires in there? Those copper wires should be wrapped in a plastic, in cloth rather. I'm sorry, in cloth tape. And I have a feeling that this fan got really, really hot. I'm about to take the back plate off and try to see if we can see a little more of that stator. But this fan got really, really hot. See how flexible these wires are here? They move, they bend, but they don't bend too great. And they got hot. I put this line cord in and connected it directly to these on the bottom and taped it. But when I tried to bend these, they were crackling and crunching because they got so hot from that bad solder joint. So that heat was like a intermittent. It was like taking a light switch and flipping it on and off really, really fast. You know, you're going to burn something out doing that, right? If you got a ceiling fan going on high and you just go to the light switch and flip it on and off as fast as you can, that's pretty much what was going on with that wire on that solder joint. It was just making connection, not making connection. It's like a switch, just doing this, just flipping back and forth. And that got everything really hot. So you can tell this hasn't been apart yet, so I haven't been in there. In fact, the first thing we'll do, because the fan is turning loose again. You remember how tight it was when it was stopped running? Now it's turning fine, just like it was when I started. So let's check the gearbox and see what kind of grease we got in here. I'm sure it's all gummy. Why do you use short screws in this fan? That's just unreal. Look at the sides of those screws. Yeah, that's what I figured. You can see it here. See how gummy that is? The old grease, it turns to glue after a while. And in here, let me get the light in there. First off, look at the shaft down there. See the rust on that? That's because it didn't have any grease on it. And then the grease is like gum, so this thing's empty. It needs to be filled. Actually, it needs to be taken apart, cleaned, and then filled. So that's not good, but that's something we can deal with. Okay, well anyway, you see how that is. So I'm going to put that back on, and we will deal with that if and when we get the fan running. But I wanted to take that off before I took the fan apart. Okay. Well, okay. I'm gonna put this on pause and put it back overhead. Okay, we're gonna go ahead and take the fan guard off. I'm trying to be delicate and not hurt the finish on the fan itself. I think I got some progress. Okay. We got the cage off. That's step one. Okay, the armature is just going to have to come out with the case. Oh boy. That's what I was afraid of. See the stator coil here. This covering is usually over the entire coil. It's possible that they made this one without that, seeing as I'm not seeing any pieces. The shim worked itself loose, but it's still in there. That's where the head wire goes through. Interesting. Head wire comes in here. Here's the head wire here. This is one here, and the other one is here. And they look like they're connected okay. If that coil didn't get too hot, we might be all right. I would expect this to be covered. But that looks original. It looks like they just put the winding in and they didn't cover it. Maybe that was to keep it cool. Maybe that was just to keep it cool. The resistance is fine. Let me see. I think I was measuring 22 ohms across that coil. Let's check it again. Of course, now I'm measuring the line cord too, so it'll be a little bit higher. 22.2 ohms. So I'm getting a reading across the coil that makes sense. 22 ohms seems about right. Because if it was shorted, I'd be getting probably a lot less than that. Let's put this back in and see if we can get it to spin again. Look at that. Look at all the grease on that armature. See that? That's just ridiculous. That's a big part of the problem there. All this grease just like exploded in here. One of the seals must have leaked. And look at, and it's in the housing too. Let me move my meter out of here so I don't get grease all over that. Okay. Let's work on cleaning one thing up at a time. Get some of the grease off here. See the aluminum under there? That's covered in grease. I don't think this has been oiled in a while either. Let's put a couple drops of oil down in there. And I usually usually use zoom spout oil, but for at this point, I'm just going to put some 3-in-1 in there just to get some oil on that armature. Okay. So the grease might have been making it stick. It's turning a lot better now. You see the difference? Okay, that's much better. Okay, let's go to this guy. In here, we get the same issue. You seen all that grease? Look at all that grease on that stator. See it in there? The only place it doesn't have grease is where the armature was sticking through the stator coil. So half the stator coil has grease all over it and half doesn't. Not the stator coil, but the core. Stator core. See this here? Okay. That's where all the grease went. That should have been in the grease bearing there. In the gearbox. It all went into the motor. Wow. That would cause issues. It means that seal in the back leaked. Now I said somebody's been in here, but now I changed my mind. I think maybe nobody's been in here. Maybe it's just grease got on those screws, and that's why they were so easy to get out. Because they were real easy to get out, like somebody had taken them out recently. But that may not be the case at all. It may be that they were just, the fan got so hot that it loosened up the bolts. Something along that line, I don't know. But I got most of the grease out of this, so we can do another test. Let's put it back together. Back in the armature, in the gearbox. There we go. Okay. That goes that way. There. Put those screws back in there. Let's see, it had 3 screws. No, back screws. These guys here. These hold the case together. Okay, that's turning a lot better. Let's see if that helps. Plug it back in. Look at that. I'm at 65 volts and it's already trying to start. So I'm going to shut it down and let's see where it starts on its own. Bringing the voltage back up. I turned the voltage down and stopped the blade from turning. Now I'm on 48 volts, 51 volts, 65 volts. Look at that. 75 volts. And we're drawing 490 milliamps, 21 watts, 22 watts. Okay, now it's getting tight again. See, I think it's the grease causing some issues there. see if it picks up speed. Something is definitely giving it a problem. Is it trying to oscillate? That's the problem. The oscillator was getting stuck. Not having any grease in the gearbox would do that. Alright, we're at 0.7 amps and it's rated for 0.8, 95 volts. Looky there. And look how quiet it is. I'm at 100 volts, 0.8, 0.79 amps. It'll be more efficient once I get it cleaned. Right now it's not quite as efficient as it should be. I don't want to go any higher than that. It's already running at its 0.78 amps is good. We have a fan. Mostly it needs to be cleaned, and we need to find out why the grease came into the motor. So obviously the grease retaining seal that goes over the bearing came loose and allowed the grease to get into the motor. So we're going to go ahead and take care of that, clean it all out. I'll take it apart, clean the whole thing out, and then put it back together, clean this oscillator off so it can oscillate fine, and this fan will be doing okay. Now as far as the switch, I'm going to try to get the switch working too. If we can get it working, great. If not, we'll have to buy another switch for it, a two-speed switch, and change it out. I'll go ahead and get some of this dirt and grime off this oscillating arm. That's probably part of what was causing it to lock up. But once I got it past that point, it went. Okay. But now it's turning so much better. So much better. Good. And we get the rest of that grease out from inside the motor, and it should spin even faster. Looks like the coil's okay, which is amazing. So it had two issues. It had a very bad solder joint, and that solder joint burnt the switch up. The second issue is because of the solder joint, it was running really hot, and running really hot probably is what made the cover of the grease seal leak, which allowed grease to get in the motor. And of course, between it running hot, not getting enough voltage, and having grease in the motor, it wasn't going to go, and it lost its grease from the oscillator, so it couldn't drive. It was putting more pressure on the fan there, and that's where we're at. So this is the initial review of the fan, and once I get this other item off my workbench, I'll get this fan running and ship back to the customer. At least now I can report back what the issue is and deal with that. Thanks for watching my video. If you found this video helpful, please like it and be sure to subscribe. This helps me to continue to make these videos, and I really appreciate that. And we will be making a part 2 on this fan once we know what the customer wants to do to continue forward. Thank you.